Hello student, in this lecture we are going to start absorption of oxygen mechanism. In previous lecture we have completed the evolution of hydrogen mechanism. Okay, so like previous one, hydrogen evolution mechanism takes place when surrounding environment is acidic. Okay, now absorption of oxygen mechanism takes place when surrounding medium is a aqueous, neutral or slightly alkaline medium. That time this absorption of oxygen mechanism takes place. Okay, before to proceed we will see more about this oxygen mechanism. This type of corrosion occurs when metals are exposed to an electrolyte of varying concentration or varying aeration. Okay, the most common type of concentration cell corrosion is a differential aeration corrosion. Okay, so this is the most common example. So differential aeration corrosion where the concentration cells are set up. It has been found that poor oxygenated part acts as anode while more oxygenated part acts as a cathode. Remember this one, this is the important one. Poor oxygenated part always acts as an anode and corrosion occurs at anode where oxidation reaction takes place, and cathode it is always protected. Okay, so more oxygenated part act as a cathode. Now for example, rusting of iron in neutral aqueous solution of electrolyte like NaCl solution in presence of atmospheric oxygen. Okay, now you are knowing when any iron surface or iron sheet, when it undergoes the corrosion, rust is formed on the surface of this iron. Okay, iron surface is usually coated with thin film of iron oxide. Okay, if this iron film, suppose this is the iron film, if this iron film has the crack, this one is iron oxide, metal oxide. Okay, by any means if it is a crack, anodic area is created. Suppose here this much part is created, so anodic area is created here, while the remaining coated part it acts as a cathode. Okay, in this crack, in this gap, oxygen or water drops, moisture, it is collected here in this anodic area. Okay, so what is happening? Let us proceed further. The mechanism you can see, for better understanding you can imagine or you can see the figure. This is a metal surface and here it is a coated part, and by any means if crack is created here and it is filled with the water and oxygen, atmospheric oxygen, this coated part, oxide coating part, it is acting as a cathode. Okay, while this cracked part, this part it will act as a anode. Okay, now see here, iron dissolve, यहाँ पे जो भी anode है, anode dissolve किसका है ये? Iron का. So with liberation of electrons at anodic areas of metal, so Fe gives Fe++ plus 2 electron. Okay, that is the oxidation. Now what is happening? The electron flows through this anodic area. Okay, the electrons liberated flow from the anodic to cathodic areas through the metal, where electrons are accepted by the dissolved oxygen in presence of water to form OH, hydroxyl ions, as below. Now you can see here 2H2O plus O2. Okay, in that gap, water, moisture, and in presence of atmospheric oxygen, there is a formation of hydroxyl ion. 4 OH minus ions are formed. Okay, at anode, what is formed? At anode, Fe++, and at cathode, OH minus ions are formed. Okay, Fe++ at anode, OH minus at cathode, diffuse and form ferrous hydroxide. So it is going to form FeOH twice, and that is the rust. Now there are the two conditions. If oxygen supply is enough, okay, ferrous hydroxide, it is oxidized to ferric hydroxide if enough quantity of oxygen is present. You can see here. Okay, first corrosion, this is a ferrous hydroxide. Okay, ferrous hydroxide is formed, and if oxygen is more, if enough quantity of oxygen is present, then this hydroxide, ferrous hydroxide, further oxidized to ferric hydroxide. Okay, this product is called the yellow rust, which decomposes to form Fe2O3, hydrated ferric oxide. It is again decomposed. This yellow rust decomposes to form the hydrated ferric oxide. Okay. Now another condition is that if oxygen is limited, if the supply of oxygen is restricted, that time corrosion product may be black anhydrous magnetite. Okay. In the previous case, oxygen is enough, so it is a hydrated product. But if the oxygen supply is limited, that time it is going to form the anhydrous magnetite, that is Fe3O4. Okay, you can see here black rust. It is also called the black rust. Okay, so clear. Electrochemical corrosion takes place by the two mechanism. One is evolution of hydrogen mechanism and another is absorption of oxygen. Okay, here H2 is evolved and in another case absorption of oxygen. Okay, so first is इन दोनों में क्या difference है? Environment कौन सा होना चाहिए? In evolution of hydrogen mechanism, acidic environment is here, and in absorption of oxygen, neutral और slightly alkaline medium होना चाहिए. Okay, alkaline और neutral medium में absorption of mechanism होती है. Second case, इसमें क्या होता है? Remember, यहाँ पे anodic area is a larger. Here anodic area is a larger and cathodic area is smaller. Cathodic area is smaller. Whereas in this case, absorption of oxygen mechanism, here it is anodic area is smaller. Okay, you can see here. This is the metal and it is coated with the oxide, and by any means if it is a crack, जो भी क्रैक हुआ हुआ पार्ट है इतना ही एनोड करके एक्ट होने वाला है. सो इन एब्जॉर्प्शन ऑफ ऑक्सीजन मैकेनिज्म एनोडिक एरिया इज स्मॉलर whereas cathodic area is larger. Okay, so all that about the corrosion.